Hello, everyone. Welcome to today's training. We are going to be looking at lesson 2 today. The topic for this lesson is Python statement. As Python beginners, it's important to understand how Python language or how Python interprets its language. How does Python communicate? What are the ideas behind this Python communication? In English language, we use statements to pass information with each other. We interact with each other with understanding that every word we spoken, the ideas, the terms, there's a meaning to it. Python have similar ways that it interacts with modules and its programs. And today we are going to try to demystify the Python statement and zone in into how we can write our own statement and how we can create commands. So join me today as we walk through this topic today. This is an important topic to me because as beginners in Python, it's important to get the foundation. We started looking last week, we started looking into the Python data types. We want to understand how Python see data. How does Python convert data? How does Python use the different kinds of data and manipulate them? Which of the data can be indexed? In today's topic, we are going to move forward to look at Python statement, how we can structure those data types into statements if need be. Remember last week, I mentioned that the lessons are divided into special topics. In the first part, we are looking at the Python basics, and we start looking at Python data types, the format and the structures. Today we are going to start looking at the Python statements, and then we'll also, last time we look at the Python loops and maybe the functions, and we'll also look at other Python basic topics. Then we are going to advance into the Python for data analysis. We're going to be looking at data management using pandas, how you can bring in your own data fusion, manipulation, how we can join tables and columns and how we can manipulate them, index them. How do we wrangle this data? We're going to also look at data visualization using Matplotlib. We are going to do data scraping. Sometimes I told you the data are not given to you. You have to find your data. And when the data are contained in websites or some resources, you want to be able to write your own Python script to get those data for you. And we are going to look into modeling with data, maybe look at machine learning and some logistic or regression analysis in Python. But again, I hope that this course will be able to build the foundation you need to advance your learning in Python. What are Python statements? A statement in Python is an instruction that Python executes by following the order of argument. Python think of a structure to follow a sequence, and when we key in those instructions and Python execute them, Python see them as statements. So Python statements contain two or more components. The two vital components that Python statement contain are the variables. We have the variables, and we also have the values. What are the variables and what are the values? So we basically assign variables are more like objects, right? So we need to assign them values so they can contain values and work with. For example, we have here, we say y is equal to 100. So we use the equal sign to assign values to variables. For in this case, y is the variable and 100 is the value. So we use the equal sign here to assign the value 100 to the variable y. And I can show you, for example, before I go on, let's turn on our Jupyter Lab. And to do that, as usual, I like to start from the basics. So I'm going to turn on my Anaconda prompt, let it load, and then I'm going to switch to my environment. So I'm going to say Conda environment list. Okay, if there's no need, about just assuming you are watching this one for the first time, you want to see your environment. So you would have watched the first video on how to install the Python, which included an Anaconda Navigator and the Visual Studio Code. The second video, you should have completed it, which is creating a Python environment. And the third video, which is installing the two packages we've installed so far, how to install the package, such as the pandas and the matplotlib. So now we've created environment in the past. So I see I have my Joken is there, and I know base is one active because of the star. I'm just going to go ahead and say, okay, Conda, activate Joken for me. So I'm saying Conda activate Joken. It's active. What I want Python to go to a directory. So I go to the module 2 for this week that I'm working on. I'm going to Control C, or once I highlight it, I'll just go to right click, copy. I'll go and say change directory, go to my working directory. So I'll say CD, which is change directory, and then I'll say Control V, and Python is going to, the Anaconda prompt is going to center at the working directory, and then I'm just going to say Jupyter Lab, JUPYTER space and LAB lab. Let Python load it. And Python is going to find the, in this case, yeah. So Python is going to center it. The Jupyter Lab is going to load in my Chrome browser, because Chrome is the browser I'm using. If you're using Firefox, if you're using Edge, whichever one you're using, Anaconda is going to find which of the browser is your default browser, and that is where your Jupyter Lab is going to open up. Okay. We are going to now look into the Python statement. So like I said earlier, in this case, I said a statement in Python is an instruction that Python executes by following the order of argument, right, in this case. So I'm going to share this Python script with you, the file, so you can play with it, change the values, change strings, and play with it, and then show you how to run those. And I'll also show you how you can create a new Python file and make it executable and all that, so you don't have that problem again. Okay, so in this case, we're looking at statement, and 100 is the value and x is the variable, so we have assigned it, right? In this case, if I run this, it's not going to do anything for me because it just knows. So running it means it's now assigning. So we use the equal sign here to assign, right? So but we can also see what's in that x, right? Let me see. So if we go further, we can see that we have another forms of statement. For example, we have welcome to Python class, right? It's a string, so we can assign a string value to a variable. So let's say, for example, let's call it note. Let's say note is the variable. Let's say note is equal to, and I'm just going to copy the string here, and I play it here. So we see that this is a string that has been passed. This string now in this case is the value, and the note is the variable, and I want to see what's in the notes. So I'm going to say print note in this case, and let Python print notes. So I'm going to comment the rest and run it. It's a welcome to Python class. So in this case, what happens is that the variable notes have a value welcome to Python class, which is a string, and by printing, we try to print notes, but we're not going to see notes. We're going to see what's inside the notes. So what's inside the note is the string welcome to Python class. That's how Python thinks. We can see other example using real numbers. So we have x equals to 100, and we try to do print x in this case. So we're not going to see x, we're going to see 100, because the x we're printing has something in it, which is a value, and the value is the 100. All right, so let me go back and look at our file. Okay. So when we talk about Python statement, the Python statement can come in three forms also. We have the multi-line statement, we have the compound statement, and we have the simple statement in Python. Right, multi-line statement in this case, Python can have many lines, and we can break that lines we can break our code into multi lines, but there's still one line of code in a way. We have the compound statement. We're going to look into it. We're going to have the simple statement, and then we can make progress from there. All right, let's start with multi-line statements. So we can use the new line command. So you see the new line. This is the the backslash command for an explicit continuation, and I will show you that. We can also use parentheses to write multi-line statement. We treat it as a single statement despite placed on a multi-line. I'll show you that on multiple lines. We can use square bracket also to create a statement that is a single line. It's a single statement, but in a multi-line. We can also use the curly bracket, right, to do that. And I'm going to show you that real quick. Let's switch back to the Python so we can see. One thing I wanted to show you also is we have other kind of input statement, for taking in values. For example, I said to add this. So we have an inbuilt command in Python that we called input. We call it input, right? And this input taking values, right? And when it takes in value, then we can convert the value to float. The value is going to take maybe a string. We can convert it then to float, and then we can print it. So let's see what's going to happen if I do that. So if I say y is equal to input, give a number. So we say you can write your function in a way and tell the users to input a number, and then you convert it to float and print it. So let's see what's going to happen when I run this. So you say give a number. So if I give a number, say I give it 50, I input an integer. This is an integer now because I don't have a decimal number in there, so it's an integer. So when I hit enter, it's going to convert it to float and print it. That's why I have 50.0, which is float. So that is one of the things we can do in Python, and we can extend it and see. Let me run this second part and see. In this case, because we already know what x is earlier, so let's run this and see. So give a number. Let me give it 50, and let's run it. So it's giving us 150 because we know that x from the previous command is 100. So 100 plus the 50, but again, it's going to treat as a float because we have a float there. So that's 150. So that is one of the things I want to show you that we have. I'm going to show you more of this command, like the input, and so another one is the print is like the output, right? So print for outputting. One to take in numbers. Python have a command called input to take in numbers. So then when we're talking about the multi-line, we can put two statements in a single line, multiple statements on a single line. And how do we do that, right? So we use this semicolon kind of way to kind of to break those statements, right? So we have this multiple statements. So if the first statement says a is equal to 100, that is the first statement because a here is the variable and 100 is the value. The second statement says b is equal to 50, b is the variable, 50 is the value. The third one, c equals to 60, c is the variable, 60 is the 100, d is equal to 120, d is the variable, 120 is the value. And but why do I have to put them into? I can break them into different lines like this and remove the semicolon, and that is the normal way people do it, right? But we can go back. We can remember that if we use a semicolon, it's going to know that the statement ends here. So the semicolon makes the Python to remember that this statement ends here. Doesn't matter if you have another statement on the same line. So you must remember to put, if you want to write multiple statements on a single line, you must remember, some people want to make their code to be short and precise, and it's a very good way to think. You always remember to use semicolon. So with semicolon, we can use multi statement. So in this case, we have assigned different values to different variables A, B, C, D, and we want to calculate the area of a rectangle, right? So we say the area is A plus B plus C plus D, assuming the rectangle does not have or equal side. The rectangle have 4 sides, but they may not really be equal sides, right? So we can think of things like the parallelograms and the rest, and then we can print that. So here we are printing. So another thing I want to mention is that we can print multiple output with one print, right? For example, here, listen, I can do. Let me do something else real quick. I can do print. I can say print A, comma B, comma C, comma D. Because I've assigned the values, I want to print it. And then let's print and see. So we're going to see when I print it. So we see they're all in the same line. Say A is 100, 50, 60, 120. I use comma to break it. Now, because these are values and these are real numbers, we can do the same for the string, right? We can say print area. So think of it that way. The whole of this is a string. It's a string, right? It's a string, and this is the area here. So that is a way we kind of concatenate. If we want to write a test to say, okay, in front of a number when we give output, that is the idea behind it. We say the area of a rectangle, then come out, because we know the Python is going to print the string out, and the Python is then going to print our real number. So when we run this, we're going to see, you see area of rectangle, you see, and is this. So that way, some people can even go ahead to put an equal sign there, but make sure they're all in the string, and at the end of the day, let me see. Yeah, at the end of the day, there's a comma, separating the string and the values, or the two statements. All right, now let's look at the multi-line statement we are talking about, the new line. So you see we use the backslash to kind of add the new line, right? And what do we mean? So Python treats this as though they are in one single line, even though they are one statement, even though they are in different line, right? So we have this multi-line, right? So we have 100 plus 200, right? Then we use the backslash to bring it to the next line. But the backslash, Python knows, because we use the backslash, they are all in the same line. With this another, we'll say 300 plus 400 plus, then we'll put the backslash again. So Python is treating that these numbers are all in a single line. What do I mean? What I mean here is that, let me see, if I say addition, I have 100, 200, 300, 600. This is how Python thinks of it, right? Yeah, so this is how Python thinks. Python thinks that what we have here in the multi-line, they are the same thing with this. So we just use a new line to break it into multi-line, even though they are one statement. But one thing I want you to understand, the reason why we do this is sometimes we have a lengthy code. You write in there, you have a lot of statements, a part of statement, maybe the part of the value or the variables, I don't know, depends on what you're doing. We use a new line to break that statement into multi-line, even though they are one statement. So that's the idea here. So if I run this script and see, Python is going to recognize that they are one statement, and it's going to do the addition and give me the value. So I say print addition 2800 for add all this. And what I just like I was saying, if I comment this and I try to do this, you see we're still going to have 2800. So that's the idea behind the new line, and I hope this information is clear to you enough. I know you were asking, how am I commenting and uncommenting? So I use the control / right, / to to comment, and you can Google it to see how to comment and uncomment in Python online. It's very simple. Or you can just put what do you call it? You can put uh, a kind of a pound in front, and it will uncomment them. Okay, let's look at another one. So we can also create another new line using just plus. You see. So instead of using we can without using the what do you call it? Without using um, the new line, which is the backslash, we can just use a plus and not use a new line, and still Python is going to recognize it. So we call it using the parentheses. But in this case, like I say, there must be a parenthesis in the front, which is the bracket. The bracket must be in front, so Python can know this is a parenthesis. It must be in front for Python to know that they are one statement, even though they are multi-lines. I'm going to run it. If I try to remove these parentheses, and let's see what will happen. You see, Python complained it's invalid syntax because Python don't understand. You see something is wrong. But if I close it back, put it in one parenthesis in a bracket, and then see, Python knows they are one statement. Again, use our square bracket, right? So we see square bracket. So when we use square bracket, in this case, we are talking about strings. Python is going to know that they are one statement, and Python is going to. So these are cars: Toyota, Mazda, Rail, Hyundai, Peugeot, Benz. So when I print, Python is going to know that different cars, 30 different cars. Let's see if we change it to the parentheses and see. This is what I talk about exploration. I want you to explore as well. Let's see if Python is going to recognize them as one. Yeah, Python does. Python see that even though they are strings and not values like the earlier one, Python knows that they are one statement, right? And the same thing happens when we use the square bracket. Python knows, and also for the square bracket, right? Python also knows for the square bracket. Python knows that. All right, this so for the square bracket, remember what we call this? This is a dictionary, right? So we use square bracket for dictionary and also sets. But for the dictionary, we have the keys and the values, right? So we have the keys, we have the values. So Python is going to know. Let's try to run it. Let's see. Yeah, because we have keys and values. So if I change it back to square bracket, let's see if Python is going to complain. And to parentheses rather than not square bracket. Python is going to complain. Let's use the other one, which is the square. It's going to complain, right? So it means we have to go back. So it's only when we have a dictionary we can only use the curly bracket, and that's the way Python's going to treat as one. So we go to the next one. So we also have compound statements in Python, and this compound statement include the if statement. The if statement executes statement under it if the condition is met or true, like conditional statement. So say if A and B is less than 100, maybe add them. So that statement is already coded. So we use the if statement to execute statement under it if the condition is met or true. Most times we use it when we want to construct a loop, and we're going to look into the loops next time. We also have the while statement, right? So these are all complex or compound statements. The while statement or looping statement executes a code block while a particular condition is true. So as long as the condition is true, the while statement is going to loop through and keep executing the program. We also have the for statement. For statement iterate over a sequence, string, list, set, or dictionary, right? Also called looping statement. We use for, right? And I'll show you this when we start looking into advanced Python programming, or maybe next time when we are looking at the loop statement, we'll look into that. We have the try. The try statement takes care of exceptions, right? Okay, try this. If it's not true, then you can end the program. We have the with statement, which allows for the initialization and the finalization of the code around a block of code, right? So we want to initialize and want to finalize our code. Is used to clean up code for a group of statements. So these if, while, for, try, and with statement, I'm not going to go, we're not going to look into it today. I just bring it up here that they are also a kind of a statement, but they are compound statement, and this statement, they are very important when we want to write complex codes. So we are going to look into it next time and see how we can use them to write Python. The last one here is the simple statement. The simple statement are in different forms. We have the first one, which is the expression statement. All right. So an expression from the word simple statement means they are simple, but they come in different forms, like the expression statement, right? Which is a combination of values, variables, and operators. You know what the operators are? The operators are the talk about the addition, the subtractions, and the rest of them, right? We have a single value all by itself is considered an expression. So I will show you what that means. An expression is just a single value all by itself, right? Expression all by itself does nothing. So we assign expression to a variable. So I'm going to show you that real quick. We'll go switch back to Python. We'll see the expression statement. In this case, right, we'll have expression. 5 is an expression. We don't know what 5. We just say this expression called 5. But is there a value? Are we assigning to anything? We have another expression called x. We have expression x plus 20. You see? So in this case, if I try to print x, right? Let's see what it's going to say when we try to print x. Yeah, so I have to, this 100 is not correct. This is not correct because in the computer memory, it's thinking of the earlier x I have. Remember in the beginning, we had x somewhere as, where is it? X as 100. So it's more. So what I need to do, and this is why I like using Jupyter Lab. So you just go back to kernel and just say kernel, say restart kernel, and restart. So it's going to clean up. You look at the right top here, it's going to clean. And when it turns circle and empty, it's done. So if I try to print x here now, it doesn't know. Say x is not defined. It's printing x because in this case, x is only an expression. We don't know what x contains. S plus 20, we don't even know. If we know x, we know what s plus 20 is. We know these are all expressions. So they don't make sense unless we add a variable or we assign value to them, right? So let's look at the next line of code. So if I want to clear my output here, I'm going to edit and just say clear output. I hit clear output, it's going to clear that. I'll go to the next one. So in this expression, we can assign expression to a variable, right? In this case now, we want to assign, we say x equal to 5. So the right hand side of the variable is equal to the expression statement, right? So x equals to 5, and we can further say x equal to x plus 10 is a complete statement in this case, because now we know what x is, and if we add, so we have x. Now this is very tricky, and this is very important that I mentioned that in Python, when we have defined x earlier, that's the x equal to x plus 10. It means we are saying add 10 to itself, to x itself. So let's see how Python interprets it, and let's try to run this code and see. Python knows it's 15 because Python knows that the x is 5 and we're adding x to x itself. So the new s is going to be 15 there. So we have the next argument, which is a pass statement. Let's try to look at it. So the pass statement is a null operation. Nothing happens when we execute it in Python. So Python knows exactly that when we use the pass statement, it's just going to stop, right? We used to create a function for future release. We don't want to use it now, but sometimes in the future. So we can write a function and say, okay, just put a pass there. In the future, we're going to use it. So look at this, for example, right? So have a function, say function 1, which takes argument 1, and we say pass. So if we run this code, it's going to do nothing. But we can use this function back in the future to do some work, and that is the reason why it's a pass statement. This function does nothing at this time, right? We have another statement called the delete statement, the del statement. The del statement is used to delete object or variables, right? like a del target object list. The target object list contains the variables to delete separated by a comma. Once the variable is deleted, we cannot access it again, right? So we use the del statement to delete an object. Let's look at a Python command for that. So in this case, for example, we have x is 100, we have y is 300, and we can print it to see what xy is. So let me do that and comment the rest and try to print this. So if we print it, say x is 100, y is 300, just the way it is. And then we want to delete it, right? So we say delete xy. It has deleted. Now let's print it again. Let's add the last print command again and see what happens. Say print xy is going to complain. You see, name x is not defined because we have deleted the xy. Python is no longer in memory, so we use a delete statement. So this is a delete statement that can delete anything. A Python statement for us. Let's go back and see the next one. We have the return statement. So the return statement is used to create value from a function when called. This return is the output of a function. So by the time we're done writing the code, we write a huge function. We must use the return function if we want to see the value in that function. We must use the return aspect, right? Let me clear the output for this one. Go back to output, clear output. So the return statement defines a function. The function accepts two or more values and return their sum. For example, we have, this is a function. So we use the def to write a function. And I'm going to talk about function writing in the subsequent class training, so you can know what a function is. Think of function like an equation. When you write the equation to say y is equals to ax plus b, and whenever you have ax, b, the y is a function on its own in that situation. Whenever we call y, and we know the value of a, x, and b, we'll have a new y. So that's the idea. So we use function like a placeholder to write like I would think of it like an equation or something, and we can then return the value, right? So a function is written by using the def. Whenever Python sees def, you know it's a function that is coming, and the function keyword here is the additions, and it takes in the values, right? The function accepts two or more values and return their sum. So the value will have value 1, value 2, value 3, and it can return value and return value 1 plus value 2 plus value 3. So this is another way we can write it, right? There's another way we can return the value. We can create another statement underneath and say the statement has a variable called sum of values, sum vars. Let me uncomment this. Say the statement have the sum vars variables and the values value 1 plus value 2 plus value 3 and return the sum value. So it must return something. So what return is the variable sum vars now. And in this case, what the Python does is, let me comment this. What Python does is it thinks of this function. This is a function, say def, and the argument is addition, then takes in the values in there, and then does something with those values. It has to work with something in those values. So it adds them by creating a new statement underneath and say the sum val. So it adds value 1, value 2, value 3, and return the sum val. So it must return something which is the sum of the values. And it means at the end of the day, in this function, the output is going to be the sum here, right? So the result is the return value. So let's see. So whenever we want to do something new, we can create new variable and assign that function to the variable. So we can say results, for example, equals to addition. Remember, this addition is the argument, right? It is the argument that succeeds the function in the function, which is additions. And you see, we will call this positional argument. In this positional argument, the Python now knows that 100, right, is value 1 because there are 3 positions, right? 200 is value 2, 300 is value 3. And when we print the result, Python is going to see this result. So we'll try to print it and see we have 600, right, in this case. And because the function here, what it does is it's kind of built from this earlier, right, function we've defined, and we call back that function. This is the callback key argument, and we assign the value, and then we can print it because we can print result. There's another way. So this is what we call the positional argument in function creation. We also have the assigning one. We are going to look into detail about functions. Right, this is a very important topic on its own. So I cannot explain everything on function and how the idea behind it in this statement topic. But I just want you to know that functions themselves, they are also statements, and the return values, and we can use that. So we're going to look into this in detail. But for now, you can think of this as functions are statement, and then what they return also return values to them. Now let me show you something. We can also just not make it complex, right? We can just use simple. Then we'll have the functions, the definition, we have the addition, value 1, value 2, value 3, and we say to return the value 1 plus value 2 plus value 3, and this is a function. We can cover that function in this. It doesn't mean, so this can change. This can change to output. So I can call this now output, and say, okay, output is equal to the function. So because the function name is addition, so the function additions, and the argument there is 100, 200, you're going to print the same, right? But we assign this function and the new input to a variable called output. So we can print that output variable, and we can see we're going to have the same 600, right? So the variable here that we use to call the function can change at any time. Let's look at the next. So the next one is what we call the import statement. The import statement is very beautiful. I love it because we use it to call our libraries. Like, it's used to import libraries from the built-in or installed packages. So Python has so many built-in modules or packages. Example is the datetime. We also have the NumPy. We have several of them. And I showed you this in the video when we were creating environment and installing packages. I told you if you look at the base environment, the base is the follow-on Python. When you look at it, you realize that it has libraries already in it, right? If you use that conda list is going to list all the environment in it. So we use the import statement to import the packages for we can use them. We can also call our installed modules, for example, the pandas or the matplotlib. We can also bring them in and work with them. Let me show you real quick. So in this example, you see we are trying to import. We are importing. So you see we can import. So if you run this line and you have not imported, you're not in your environment. You're not in the environment you created, right? This is going to break for you because if you're not in that environment, means you have not installed pandas and matplotlib, right? So the packages I told you to install them, pandas for reading tables and analyzing tables, and matplotlib for visualization, they need to be in that environment. So you have to make sure your environment is activated, and then we can do. So you can import data. Datetime is already inbuilt, but we install the pandas. So if I run this, it's gonna run, but because I am not using it, so I'm just going to run it. See, it's going to run and complete. Yeah, so it's done. It's done running. So the library is now ready to be used. And we can do more things here. Right? For example, I want to use the date time to see what is my current date time from here. So we assign. So we use the idea here that we use the library date time and assign function to it, which is the function here. Let me see. The function is datetime.now. So it means this function says give me the current time, date and time, and assign it to the variable now and print it. Let me see. So if I run it, it's going to give me. So I see I have my date time. It says this is 2023 October 8th, 11:29, and these are the seconds. Right, that is for my current time, my own current time. So it's going to look at my system time and use my system time that you see here to give me the result there. So this is how we write statement in Python. And switching back, we can see we also have other statement in Python. We have the break statement, which is used in a loop to exit out of a loop. So we're going to look at when we start treating loop, we're going to use that. We have the continuous statement used to skip any current iterations and move. Sometimes the way you write code can damage your computer, and I want to mention that, right? If you write if you write a code and you're not careful, your computer can run out of memory and crash. So we'll use some kind of break statement to break out to exit the loop, and we use continuous statements to skip any current iterations and move to the next one, right? So that is what we do there. So we are going to look into this when we are treating the loop, so I can show you example of commands, Python commands we can do there. And we have done some demo already. I've showed you those codes. I showed you all the various Python statements, the printing statement from creating output, the input statement to take in values. We have the multiple statement on a single line, the new line statement, so we have expression statement, pass statement, delete statement, return statement, import statement. There are several of them. So we've looked into all the statement types. And yeah, so for the assignment for this week, I want you to first play with the different Python statements to understand how they work in Python. Use your own values, change them, play with different data types, and see if it's going to work with the statement, different data types. Write your own statement using your own set of variables and expression where necessary, just so you can submit this on the I'm going to create a new folder where you can submit your assignment. But the idea here is that you write your own statement and you use your own variables, make up your own variables and expressions, and make sure it runs, and write any reports on what you find. And this is where we call it a close. And I hope you are able to learn from this Python statement, and I will see you on the next one. Thank you for your time and have a beautiful week.